Okay, number 7 is a stoichiometry problem. How many moles are in 75.0 grams of nitrogen gas? All right, so in this problem, you need to write down what you're given, which is 75.0 grams of nitrogen, and we are looking for moles of nitrogen. Okay, so our mole map, we're trying to get from grams of nitrogen into moles of nitrogen. That's the same substance, so this is a one-step conversion. All we need to do is molar mass. So 1 mole of nitrogen is equal to blank grams of nitrogen. We have 2 nitrogens in the nitrogen molecule, so that's 2 times 14.007, which is 28.014 grams. We'll put that up in our blank for our equivalent statement. And now we can do our equation. So we're given grams of nitrogen. We're trying to get into moles of nitrogen, the same substance, which means we need grams of nitrogen on bottom to cancel it out. And then we just put in our numbers. We're given 75.0 grams of nitrogen, and our equivalent statement up here, 1 mole is 28.014 grams, is then what we put in these spaces here. So 1 mole of nitrogen, remember molar mass is always 1 mole, is 28.014 grams of nitrogen. Alright, so really all we're doing is taking 75.0 and dividing it by 28.014. And you get 2.6772 on the calculator. And then the last step is to do our significant digits. Our given has 3, our mass has 5, so we need to take our answer to 3. The 7 rounds a 7 up, so this becomes 2.68 grams of nitrogen. Alright, number 8. A student burns 1.50 moles of C3H8 according to the following reaction. C3H8 plus 5O2 yields 3 CO2 plus 4 H2O. How many grams of carbon dioxide are produced? Okay, so we got 1.50 moles of C3H8. There's our C3H8. And it says how many grams of carbon dioxide are produced. All right, so even if you don't know exactly what carbon dioxide is, it says produced, so you know you're on this side. I sure hope you know that that's water, and honestly, you should really know that this is carbon dioxide. Okay, so that means that we're going from our C3H8 to CO2 here. We're starting with moles, okay, and we're trying to go to grams. So we are given 1.50 moles of C3H8, and we are looking for grams of CO2. Alright, so mole map wise, we are starting with moles of C3H8. First, we have to get into moles of CO2 before we can go to grams of CO2. There's no straight conversion from moles of one substance into grams of another substance. So how are we going to get there? Well, mole-to-mole ratios is our coefficients, which is 1 to 3 is our mole ratio. And then, of course, between moles and grams of the same substance is always molar mass. So this is 2 equivalent statements. Blank moles of C3H8 equals blank moles of CO2. And then remember again, this is just the coefficients. There's no number in front of the C3H8, which means it's 1, and CO2 has a 3 in front of it. So this is a 1 to 3 mole ratio. And then we do our molar mass of carbon dioxide. So 1 mole of CO2 equals blank grams of CO2. We have 1 carbon. We have 2 oxygens. 1 times 12.0, oops. 12.011 is 12.011. And we have 2 oxygens, and they each have a mass of 15.999. So 2 times 15.999 is 31.998. And then we have to add those two up. Okay. So doing our equation, we're starting with moles of C3H8. And we have to get out of moles of C3H8 and into moles of carbon dioxide first, before we can get out of the moles of carbon dioxide and into the grams of CO2. Now remember, this top part of our equation here is the same thing as our mole map. Moles of one substance to moles of the second substance into grams of that substance. And that's exactly what we did here. Moles of C3H8 into moles of CO2 into grams of CO2. And then remember, our other units just get canceled out by putting them on bottom. So now we just stick our numbers in. We started with 1.50 moles of C3H8, and our mole to mole ratio, there are 3 moles of carbon dioxide for every 1 mole of C3H8. And then we put in our molar mass, which for some reason is not showing up. Hold on just a second. Okay, which remember is 44.009 grams of CO2 for every 1 mole of CO2. So math-wise, what are we doing? We're multiplying straight across here. 1.5 times 3 times 44.009. And when you do that, you get 198.04. Okay, so significant digits. Our given has 3. Remember, mole to mole ratios are exact. And our mass has 5, which means we need to take our answer to 3. So final answer is 198 grams of CO2. Alright, number 9. In this problem here, in 1860, Robert Boyle was the first to use phosphorus to ignite sulfur-tipped wooden splints that gave rise to our modern matches. One of the ways it can be made involves the chemical reaction of calcium phosphate with carbon and silicon dioxide in a furnace. And this here is the balanced chemical equation for this. We know it's balanced because we have coefficients in here. So it says starting with 100 grams of calcium phosphate and an excess of silicon dioxide and carbon, how many moles of phosphorus will be produced? So since we have an excess of silicon and carbon, really what we're worried about is this calcium phosphate. So we have to know what calcium phosphate is in this equation. Well, you need to know that silicon dioxide, even if you don't know exactly what it is, you know it has silicon and you know it has OX, you know it has oxygen in it, so you should be able to figure out that it's this one. And then carbon, obviously, is this one. So the only one with calcium in it as a reactant, because it says starting with, is this one here. And of course, phosphate is PO4. You can look up phosphate on your polyatomic list, so you should be able to figure out that this is calcium phosphate, even if you don't recognize it right away. And then it says how many moles of phosphorus will be produced. That means you're looking for phosphorus by itself, and the only product, which is phosphorus by itself, is this one here. So that means we're going from calcium phosphate, the substance that's first in the equation, to phosphorus here at the end. Okay, and we are going from grams of calcium phosphate into moles of phosphorus. So we are given 100 grams of calcium phosphate. And we're looking for the moles of phosphorus. Phosphorus, when it's by itself, has 4 bonded together to have a stable structure. So we need to go from grams of calcium phosphate into moles of calcium phosphate, and then into moles of phosphorus. Okay, so there's our mole map. Remember, we have to go into moles first. We can't go straight to moles of a second substance. So that means this is a 2-step. First thing to go from grams of a substance into moles of the substance is always molar mass. So remember, molar mass is always 1 mole of your substance. And I apologize for my ugly handwriting. The stylus is not working real well for me. So 1 mole is equal to blank grams. So we have 3 calciums. Okay, so that's 3 times 40.078. And then you have to understand that you have a 2 outside this parentheses, which means everything inside has to be multiplied by 2. So that means we actually have 2 phosphorus. So that's 2 times 30.974. And that means that we have 8 oxygens. Alright, so 3 times 40.078 equals 120.234. 2 times 30.974 is 61.948. And 8 times 15.999 is 127.992. And then we have to add all those up. And you get 310.174. And then you do your mole to mole ratio, blank moles of Ca3PO4, which is calcium phosphate, equals blank moles of phosphorus, P4. Alright, so we use our coefficients for this. 2 moles of calcium phosphate for every 1 mole of phosphorus, and we use a 1 because there's no number in front. So this is a 2 to 1 mole ratio. So in our equation, this is a 2-step, we're going from grams of calcium phosphate. Sorry for the bad handwriting, guys. The stylus is not cooperating. Into moles of calcium phosphate, which means we need grams of calcium phosphate on bottom And then we go into moles of phosphorus, P4, which means that we need out of moles of calcium phosphate. Okay, so substituting in our numbers, we have 100.0 grams of the calcium phosphate. It's always 1 mole per molar mass. And we are given the mass of 310, 174. That's what we calculated. The molar mass of calcium phosphate was. And then we do our mole to mole ratio. There's 1 mole of phosphorus and 2 moles of calcium phosphate. So math-wise, what are we doing? We're going to divide 100 by 310.174 and then also divide by 2. If you don't like doing that, you can multiply straight across the top, get a number, put it up here, multiply straight across the bottom, get a number, and then divide your 2 answers, whatever you want to do. Alright, so what do you get when you do that? You get 0.1611998 on the calculator. And the last step is to do your significant digits. The given has 4, our mass has 6. Mole-to-mole ratios are always exact. So that means that we need 4 in our final answer. The 9 will round the 1 up, which means that we have 0.1612 moles of phosphorus. That's the final answer.